Hi, it's Mr. T here. In this series of videos, I'm going to go through how to answer exam questions so that you get the best out of your writing when you're sitting exams. If you find this video useful, don't forget to click a thumbs up, subscribe, and then click that bell for notification if you want to see the next video. Hi, in this video we're going to look specifically at geometric isomers and how we might answer questions on those. This video specifically focuses on NCEA Level 2, but it is helpful for anybody who wants to know how to write a good explanation about what geometric isomers are and what are the requirements for a molecule to be a geometric isomer. Okay, so let's look at how to answer some questions on geometric isomerism or about geometric isomers. This first question comes from NCEA. It's the 2021 exam, and it's question 1B. If you want to find this paper so you can look through it as I go through how to answer this, you can just use the data at the top right here to search up in any search engine to find a copy of the paper. Righto, so in this question they've asked us, they've said that this molecule, compound 3 at the top here, which we can see has 6 carbons and a double bond off the third carbon, so it's hex-3ene, this molecule can have geometric isomers. And the first thing they want you to do is to draw the geometric isomers. So, the usual way that I would draw geometric isomers is in fully expanded form. And because it's got cis here, and cis we know means that we have the groups that are identical, either both coming off the bottom or both coming off the top. Here I've drawn both the hydrogens off the bottom. Okay, so this is drawn the cis isomer. And then the trans, of course, means opposite or across. So I've drawn the 2 hydrogens across the double bond here. So that has fulfilled the first question that they wanted us to do here. The next thing they want us to do is explain why this could be a geometric isomer. Now there's 2 key reasons. The first one is they have a double bond. You cannot be a geometric isomer without a double bond. So before I go and answer the question, notice I've just put a 3 and a 4 up here, and I'm going to write a 3 and a 4 here because I'm going to use that to reference in my writing so I can give the detail needed to answer this question at an excellence level. Okay, the first thing I'm going to say is compound 3 has a double bond. This double bond prevents the molecule from rotating around these carbons, around carbon 3 and 4. So this is where I've put the detail in. So it holds the molecule in a fixed position. It either holds these 2 hydrogens down or them across. The second thing that is a requirement is that each carbon, both carbon 3 and 4, must have 2 different substituents or 2 different groups / atoms. So if we're going to say atoms or groups, we have to put / and put both of them down. So it has 2 different ones bonded to the third carbon and the fourth carbon. So I've put my detail down here, and I've said exactly what the groups are. The groups are a hydrogen and a CH2CH3 group or an ethyl group. And then I've said, look, it's the same on both sides. So it's met both of those requirements. It has a double bond and it has 2 different groups coming off each carbon of the double bond. Because there are 2 possible arrangements of the hydrogen, you can either have them both at the bottom, you could have drawn them both at the top, that's the cis arrangement, or you could have them both across, that's the trans arrangement. So this here is a fully detailed explanation. This meets all the requirements. So I've drawn the cis and trans isomers. I have stated that the carbon-carbon bonds and 2 atom groups on each carbon of the double bond. So we've stated that, but we've given the detail of what they are as well. And I've also gone and sort of said what cis and trans is. So I've fully justified the structural feature on compound 3 that allows for geometric isomer. So I've put all the detail needed for an excellence. Notice this question gives me 2 achieved points, 1 merit point and an excellence point. For the way that this exam is structured, you need to get, in this part of the paper, there being 3 questions. In the first question, you need to get 4 A's to get the top A grade, which is A4. You need to get 2 M's to get you an M5, and you need 2 E's to get an E7. So actually, if you ask this question really well, you've got a really good start on passing the paper or doing well on the paper. Let's go look at the next one, 2022. Okay, 2022, they've structured the question a bit different. So they've given us 2 different compounds, and they want us to identify which one is a geometric isomer. So if we look at compound A, we can see it does have a double bond. That's awesome. But notice, because it's at the end, this carbon has 2 identical atoms coming off it. So it doesn't meet both requirements needed to be a geometric isomer. If we go to compound D, we can see that the 2 carbons, the second and the third carbon, actually have a double bond. Cool, meets first requirement. Second requirement, does it have 2 different groups / atoms? Yes, it's got a hydrogen and an H3C or a CH3. The other carbon has a hydrogen and a CH2, CH2OH. So yes, it meets both requirements. So it's compound D is the one we're going to circle. Awesome. That will give us the answer for this if we can draw it. So we expand this out and we draw it fully like this. Cis, I've put them both on the same side, both hydrogens down the bottom. Trans, I've put them across, one on the top, one on the bottom. Awesome. So that gets me the achieved for 2022. Remember, if you want this paper, if you want to practice this as I go through, just search that up in a search engine and print them off. Okay, there's a second part to this question, and we're going to expect this. We expect to do a bit of graphical work by drawing the molecules, and then we're going to have to explain them. So what are the requirements? We have to describe, explain why only one of these compounds forms geometric isomers. Remember, we identified them. And your answer should describe the requirements. We talked about those, a double bond, and each carbon involved in the double bond must have 2 different groups or atoms coming off them. Explain the importance of the double bond. Well, that's just referring to the double bond holds these groups, atoms coming off the carbon here in a fixed position so it can form a cis and trans. Refer to the structures means that we're going to have to give some detail. What are the specific atoms? What are the specific groups? What carbon do they come off? Do they come off carbon 1 and 2 or carbon 2 and 3? So I go back up to the top for a start, and I'm going to notate. I actually only needed to notate D here, but I've been thorough. So now I'm going to write my explanation. What are the requirements? Okay, compound D has a double bond. Awesome. Prevents rotation, holds these atoms / groups attached to the carbons that are part of the double bond in a fixed position. That's why that's one of the requirements, but I've also explained the second bullet point here. The second requirement, carbon 2 and 3 have 2 different atoms groups bonded to them. So carbon 2 has 2 different groups bonded to it, an H and a CH3. Carbon 3 has 2 different atoms groups bonded to it, an H and a C2H2OH. So they can hold these molecules either in a cis or trans arrangement. Cis arrangement, they're both up. Trans, they're both down. So, did I meet the requirements needed for the answer? Sorry, I forgot compound A. Compound A has a double bond. Awesome. But it's not. It could be a geometric isomer, but it isn't, because carbon 1, 2 identical hydrogens, can't be, right? Needs 2 requirements. It needs to have a double bond, and each carbon that is part of the double bond must have 2 different groups / atoms coming off it. This doesn't. Compound A doesn't meet the grade. Okay, what do we need for the answers here? So thinking that the previous slide had, if you drew them correctly, you got 1 achieved point. If you state that you need a carbon-carbon double bond and 2 different atoms, you get the second achieved point. Okay, or atoms or groups. Okay, so that's 2 achieved points. That's similar to the 2021 answer. You've stated the 2 requirements for geometric isomers. So you could, instead of doing both this, you could say generally what are the 2 requirements. That would be the way that I see it here. Did you explain why the carbon-carbon bond is needed? That's another achieved point. It was needed to hold it in fixed position. Did you explain why two different atoms are needed off the carbon? That's really us unpacking this last sentence of the second bullet point here, saying that, look, when we have two different groups, we can then look at the arrangement of the two similar groups, and they can either be arranged both above or below cis, or one above and one below the double bond trans. So we need that really to get up into our merit for this one. And for excellence, we need to combine all of this, and not forgetting to talk about compound A and why it doesn't meet the requirements. Notice here it says fully justified for excellence the features of compound 3. Now what they mean by the features of compound 3 is that you have put specifically the atoms and groups that are coming off the specific carbons. You've put that detail in, and that's what you need to get the excellence. So again, this actual marking scheme here for this question in the paper is going to get you a long way down the road towards passing the first question, or doing well in the first question in the exam. Okay, one last one. This is last year's paper, 2023. Well, last year as I record this is the start of 2024. So here's the question. Propose a structure of a compound with a molecular form of C4H8 that forms a geometric isomer. Okay, so a bit of creative work here, but we can see that there's 4, so it's going to be a butene. And look, if we've done enough practice in organic chemistry, we're going to know it's going to be but-2ene. It can't be but-1ene, because then you would have 2 hydrogens coming off the first carbon. We draw the structure. Here it is. It says here, you do not need to draw the cis or trans arrangement, but look, naturally when I draw them expanded, it's either going to be cis or trans, and you can see this is a trans here, but that's fine. So I've drawn that. Now I've got to restate the requirements of geometric isomerism. So again, we're going to I've set up here, I've put 2 and 3 to help me just tie my answer to the graphical representation. So this compound has a double bond, prevents rotation, holds the atom groups of the double bond in a fixed position, or attached to the double bond. Okay, this statement, notice, is needed every single time, right? So this is achieved. This is going to give us, get our 2 achieved grades for us. And to get to the next stage, we just need to clearly say, okay, these are 2 different groups, because one is, or atoms, because one is a hydrogen and one is a CH3. So coming off 2, there is a hydrogen and a CH3. That's what makes them different. And coming off 3, there is a hydrogen and a CH3. Hence, we have our answers. Draw the structure, we get an achieved point. If we state the requirements, first bullet point, we get an achieved point. If we explain why it's needed, actually that's this part here, fixed position, that's a merit point. Well, that's awesome. So actually if we do this part here and the first bullet point, if we draw the diagram in the first bullet point, we're going to get achieved merit. Excellence is this detail. Okay, justifies the proposed structure by linking both criteria. So I'm linking by putting the specific groups and the specific atoms joined to the number of the carbon. I'm linking what I'm talking about to the actual structure. And in this case, actually, sorry, the fourth one is a merit point. So there's 2 merit points to achieve. Now, it's interesting. Sometimes they make it an excellence answer. Sometimes it's 2 merits. But if you go through this whole paper, you can see that this question, geometric isomerism, is a real linchpin. And if you just practice these and you make sure you're familiar with using the correct phrasing, with drawing the molecules correctly, and linking, okay, linking the specific groups or atoms off the specific carbons of the double bond, when you write your answer, you're going to get the maximum grades from this, and you're going to go really well on the exam. Hey, good luck with your practice, and thanks for listening. Okay, if you've got to this part of the video, you've obviously watched all the examples that I had on those 3 questions. Hopefully this has fortified your understanding of geometric isomers, and you are now well prepared to go and attack that exam. Good luck, and if you found this video useful, don't forget to like it, subscribe, and look out for new videos that I might put up by clicking that bell. See you later.